I'm Dr. Jagadha, Associate Professor in the Department of Mathematics. Today the topic for discussion is question bank discussion on Laplace transforms. First we will discuss Laplace and inverse Laplace transform regarding this module 1, which is in the question bank system. Complete nearly 50 questions we are going to discuss about it. The question bank system, which is divided into 3 parts. The first part is short answers, that is 20 questions which comes under part A, and long answers 20 questions under part B. The finally question bank, problem solving and critical thinking, nearly 10 questions are occurring. This complete the question bank system according to satisfying Bloom's taxonomy. Totally 6 levels are there, Bloom's taxonomy. The first 3 levels satisfying this question bank of Laplace transform, the module which is prepared. So this is Institute of Aeronautical Engineering, the question bank system. The subject is mathematical transform techniques, in which totally 5 modules are there. The first module is Laplace transforms. The code for the subject is AHSC07. And this is the course for BTech first year students. And the regulation is R20. So the question bank which is prepared satisfying Bloom's first 3 levels, that is remember, the second level understand, the third level apply. So the entire the Department of Mathematics, Institute of Aeronautical Engineering put together the frame of this question bank which is prepared. Dr. S. Jagadha, Associate Professor, myself is a course coordinator of this subject. So the Bloom's taxonomy, so we can see it here. The first level, which is remember, what also for we studied in the earlier classes, definitions, formulas. Just we will recollect or recall. Then recalling those formulas, we will increase the understanding level, we will increase. So recalling, understanding the defined formulas, we will apply in the problems for the solution. So this is only our target. Based on this, the question bank for this module 1 Laplace transform which is prepared. The 4th level is analyze, a little bit high level. But the thing is that the subject, the Laplace transform, up to 6 levels, the questions will dominate up to research, because which is plays the role of especially ECE students, and the transformations, the Laplace in signaling, which plays a role like anything. But as this subject, the mathematical transform techniques, for the first years, so we concentrated only up to 3 levels. The 4th level analyze, 5th level evaluate, and the 6th level is create. So if you are taking the Laplace up to create, we can. That is for BTech. For the final year students, these levels will be there. 2nd, 3rd and 4th year, their question banks will be dominating their core subjects. These levels will be there. Now coming to the point of our subject, mathematical transform techniques, only the Bloom's 3 levels we are going to concentrate. So we can see the Institute of Aeronautical Engineering Question Bank, the Model 1 Laplace Transform short answers. We can see here define the first question, define Laplace transform and write sufficient conditions for the existence of Laplace transform. Just what is the formula for Laplace and their existence, what is the conditions which are imposed on it. Only we are going to recalling. So remember it is there. Bloom's first level. When we are coming to the second question also, state first and second shifting theorem. So the statement only we are going to, that is a question which is asked. So remember. So only the recalling work that we are doing. Whereas the sixth question, if you are taking state and prove linearity. So first, the statement we will remember, the first level is over. So what are the terms we are taking? That we will understand. That is our Bloom's second level. Then we have to prove the linearity property. So what we understand that along with the defined statement of linearity, we will prove the theorem. That is linearity property will be proved. So apply. Here also we can see it or what all the steps we have done it. Recalling and we are explaining the property of Laplace transform in linearity. Level 1 and level 2 satisfying, we will move to the third level, that is apply. So this is the basic concept of satisfying Bloom's 3 levels, the question bank for the subject mathematical transform techniques which is prepared. This question bank which is available in our college website, Institute of Aeronautical Engineering. Now, what are the questions which are dominating in the question bank? The main questions we will discuss, but not complete solution. Complete solution will be there under separate topic which are done already, which is already released with the YouTube channel. Here we are going to discuss the first level, what are the formulas to be recalled, what is our understanding level of that recalled, the defined formulas, how they are have the connectivity towards our problem. This is our second level. Then third level we will apply correctly towards the required solution. So on this basis, completely the question bank we are going to discuss. The first one is the definition of Laplace transform. Let f of t be a given function and defined for all positive values of t. Then the Laplace transform of f of t, that is a function f is there which is defined in terms of the variable t. Then capital L which it denotes Laplace transform of the function f of t. Otherwise, the mathematically L of f of t, which can be in another way, f bar of s also we can denote it. Now here which is written L of f of t, that is f bar of s, which is equal to integral 0 to infinity e power minus st f of t dt. That is our f of t which is multiplied by e power minus st, and we have to do the integration with respect to t and the limit range from 0 to infinity. This is the definition of Laplace transform. Here, compulsory the integral should exist. Here we are noticing the s. It's nothing but S can be the parameter real or complex number, real number system, natural, whole, integer, or rational, irrational, put together the real number system, otherwise complex, the square root of negative number. So anything will be of this particular S. Now, f of t, that is L of f of t, which is equal to f bar of S. Just L we push towards the next side, it has become L inverse. Now, f of t, which is called now inverse Laplace transform. The capital L, the transforming work which is taking place using this Laplace operator capital L. That is f of t, which is transformed to f bar of S. That is f bar of S, it's nothing but L of f of t. This to be noted forever, we have to remember. This is called Laplace operator. That is, what is the work the Laplace operator it does? L inverse, which transforms f bar of S into f of t. This is called inverse Laplace operator. Just the question bank what we are going to discuss, for which L and L inverse, these two symbols are dominating. Laplace transform, capital L plays a vital role. Inverse Laplace transform, L inverse, which is playing the role. So initially in advance we discussed about it, because the question bank problem what we are going to solve, these two symbols L and L inverse, they are dominating. Now this is the question in the question bank, sufficient conditions for the existence of Laplace transform of a function. So the function f of t, it must satisfy the conditions for its existence. The first one is it should be piecewise continuous. That is, suppose the t, if you are taking lies between 0 to 5. So the next one is t is greater than 5. For this, f of x one function we will give. For this, another function we will give. That is 0 to 5, when we are plotting one, suppose satisfying that one plotting one curve we will be getting. 5 to infinity, another curve will be getting. But both the curves are discontinuous. But at each point of this curve is continuous. This also at each point of this curve is continuous. Such type of the continuous functions are called piecewise continuous. So now, so that's what which is written here. Our t, which lies between a and b, everything they are positive. So greater than 0, which is written. The complete one, which is greater than 0. The second condition is the function should be of exponential order. This regarding this, one question bank problem also is there. In this video lecture only, we will discuss about it. Now, the Laplace transform, applying, we can see it. The Laplace transform, which is defined by, we know this is the formula. Here we are taking a small function, that is L of we are taking L of t. How our Laplace formula, which is connected to our function. The first level we completed, Bloom's remembering Laplace formula. Now we wanted L of t. Then understanding Bloom's second level. So our f of t, in the place of f of t, t is there, that is t power 1. So f of t in the Laplace formula to be replaced by t. We replaced it. Then e power minus st, e power minus st, f of t place we put it t. So any function which is given, that to be done, this is the way. Then we will be doing the integration. This integration is the t we have taken and we have done it continuously differentiation. And this exponential part of the term, we have done it integrated 1 we have written here. That is e power minus st, the integration is e power minus st divided by minus s. Again, keep on, we will be doing integration. E power minus st divided by minus s, but already minus s there, so minus s the whole square. Between the terms, we can see it here, minus is there, here plus is there, and we stopped the procedure. If continuous, next to plus, minus, plus, it goes on. Alternative signs are in between the terms. That is according to this integration technique. So we have to do the integration and we will substitute the limits. Upper limit minus lower limit. We are obtaining, this is the result. So this complete, actually that's what the starting only I told, each and every step, more explanations. Here, this video lecture, defined formulas, understanding level, applying. These 3 levels, how the question which is connected, that we are going to discuss. If complete solution, the particular thing wanted separate video, under which nearly 11 videos are done on Laplace Transform. Now, so the f of t, t power 1 we have taken, replaced it. This is the result, we obtained it. Now, every time, suppose sine at is there, here substituting and we have to do the same similar way. But few are trigonometric terms, that is elementary functions, that these are the steps of following. We can see it. L of t, we checked it in the previous slide. Now our f of t is k. The same manner if we do, this is the result. So while solving the problem, suppose in case L of k which comes, we no need to do complete steps. Just we can put it while solving the problem, since L of k equal to k by s. L of 1 equal to 1 by s. If you want to test whether this result is correct, that is a previous step, the same steps to be followed, we will obtaining these results. The standard results, L of t power n, it's nothing but n factorial by s power n plus 1. 2 we can, that is t power n. If it is positive integer, we will be taking this formula. If it is, that is greater than minus 1 or fractions, we will be taking gamma of n plus 1 by s power n plus 1. Sin at, cos at, very, very important. These are complete problems. Without that, what we are here, it is there in this slide. In the problems, compulsory, these terms will be dominating. So when these terms are coming in the problem, We no need to do long steps. Straight away, this Laplace transform of cos at is there. Since we can put it, we can write these formulas. So we can see here L of sin at and L of cos at is there. Easy to remember. If sin comes, the numerator is dominated by A, whereas cos, it is dominated by S. It's not any Laplace transformation technique. Just to remember purpose, we are following some technique to forever to remember the formula. And here, sin h and cos h is there. These four formulas forever to remember. Sin h, whatever it is there, regarding the trigonometric term sin, the numerator will be dominated by A. Cos or cos h, numerator will be dominated by S. Without h between positive sign, h is there, negative sign. Like this elementary functions formulas, we can search easy way how to remember. Then we won't commit, because what is the formulas are defined on that basis only, solving the problems depending. So we have to remember the formula. To remember purpose, any good method to keep in our mind, we can adopt it. Now, this is the question which is dominating in our question bank. That is Laplace transform of cos h cube 2t. Here we can see it L of cos h cube 2t. Whenever the trigonometric term which has the power, immediately regarding any trigonometric formula is there, we have to see. So this is the formula. The main reason is, one more reason also it is there. The previous slide, what we discussed it, we have the Laplace transform for cos at and cos hat. These two only regarding cos we have that Laplace, the elementary functions. But here cos cube is there. The limited formulas, with that we have to do it. Better cos h cube related the trigonometric formula we have taken. We are doing so according to Bloom's. We recollected this trigonometric formula. Next we will move to Bloom's second level understanding. So this is the formula. In the formula capital A, what about our problem? 2t. So capital A, which is equal to 2t, we are substituting both left and right. We obtained it cos h 6t, which is equal to 4 cos h cube 2t minus 3 cos h 2t. So wherever A is there, we replaced it. So just we need it. What is our requirement? Cos h cube 2t. So according to that, the simplifications we have done it. Now we want Laplace. So both the sides we are taking Laplace, and here the 1 by 4 constant we have taken. So Laplace of two terms are there. Again we are going to face the problem, because L of a single term, we know it, cos h at formula, S by h is there, s square minus a square. But L of two terms, what to do? So another property it is there, linearity property. The linearity property, how it is functioning, that is Laplace of two or more functions, whatever it is there, which is equal to each function Laplace, their sum, we can write it. So using that property, now separate first we are writing L of this first, L of second one. This is very easy now, which is the formula cos HAT. Numerator will be dominated by S divided by S square minus A square. Our A place is 6 is there. Here our A place is 2 is there. We applied the formula. So this is what, this is the Laplace transform of cos h cube 2t. We discussed it. And more simplifications doing, we will reach the answer. So the next question which is in our question bank is L of e power minus t cos square t. If our question L of e power minus t is there, easily we can do it. 1 by s plus 1. Because we have a formula e power minus at, it is 1 by s plus a. But it is e power minus t, a one term, and multiplied by another one, cos square t. Yes, we are facing the problem. Cos square, we don't have. We have only L of cos t. If it is there, we are very comfortable. But cos, the trigonometric term, which has the power 2, is there any formula to replace the particular term cos square? So we are thinking over that. So we can see it here. First, this cos square we are taking. We are doing the work. So the work cos square t, which is replaced by the corresponding trigonometric formula, 1 plus cos 2t divided by 2. This constant we have taken out using the linearity property. So that's what here we are recalling our linearity property. According to that, we can write Laplace of first term, Laplace of second term. Now very easy. L of 1, elementary function, straight we can write it 1 by s. Cos at, cos, immediately numerator should be dominated by s. By s square plus a square, our a place is 2. This we have to do the simplification. But our question is, we focused on only cos square. But our question is cos square, which is multiplied by e power minus t. So this to be, now we have to focus. This simplification which is done here, all are the simplifications. Now, so the e power minus t concentration is whatever the f of t. Our f of t is now cos square t. That is simplifying. Already we obtained, this is the result. If it is multiplied by e power minus at, then what they are saying, f bar of s, that is s, better you replace it by s plus a. According to that, this is our complete question. This already we found, this is the result. The result will be in terms of s. S should be replaced by s plus 1. Because here minus 1 is the coefficient. Suppose in case in this particular place plus 1 is there, then s minus 1 will be written here. Now our problem, wherever s, we will replace it by s plus 1. So replacing wherever s, which is replaced by s plus 1, and simplifications to be done. The next problem, which is dominating in our question bank, that is find the Laplace transform of g of t. So the g of t, the condition which is given, if t is greater than pi by 3, this is the function. If it is less than pi by 3, this is the function. What about our f of t? L of f of t, it's nothing but f bar of s. We can see it. This problem, how to solve. We can see here, L of f of t is f bar of s. G of t in second shifting theorem, we are going to apply here. We recalled the formula. F of t, g of t. We have to formula, we recalled it according to Bloom's first level. The next level, we will understand what is the connectivity of the two functions, f of t and g of t. The connectivity of f of t and g of t, that is the g of t which is defined in such a way that f of t minus a. If t is greater than a, f of t minus a. If it is less than a, that is 0. Yes, we will compare to this. This is the question which is given, cos of t minus pi by 3, from which we can extract. It is in the form of f of t minus a according to our second shifting formula, defined formula. Here a is there, here pi by 3 is there. So f of t minus a, f of t minus pi by 3, cos of t minus pi by 3, we can extract what is f of t. F of t is nothing but, without a we have to write cos t. After getting this f of t, that is cos t, L of f of t, which is multiplied by e power minus as. In general, which is given, this complete one is the defined formula for second shifting theorem. Just we are understanding, giving the connectivity to our problem. However, according to our problem, f of t is from which we are extracting cos t, e power minus as. Our a is pi by 3, which is replaced it. So cos t, the Laplace is s by s square plus a square. Here cos t, the t coefficient is 1. So we solved the problem. Here we applied it, our defined understanding, the application applied, the defined and understanding one to reach the solution. So the next question, which is in our question bank, find L of e power minus 3t sine h 3t using change of scale property. Here we can see it, L of e power minus 3t sine h 3t, just we are writing the question. Using first shifting theorem. The first shifting theorem, anything, the term which is multiplied by either e power minus at or e power at, we will recall first shifting theorem. So this is what our first shifting theorem, that is f of t, which is multiplied by e power minus at. Then the final result, s is replaced by s plus a. Now we can see here L of sine h3t, this part L of sine h3t. Here e power minus 3t is there, that is s which is replaced by s plus 3. Strictly in the question which is given, use change of scale property. Otherwise, if it is not mentioned, we know sine h3t, the formula sine hat. What is the result in which s can be replaced by s plus 3? That way also this problem can be done for the solution. Now, if it is told change of scale property, we are using that one. The change of scale property, that is f of t, in the place of t, at will be there. Ours is 3t is there. That means our a is 3. What is the answer? What is the result for the change of scale property? 1 by a, f bar of s. S is replaced by s by a. So we can see it. So 1 by a, f of t. In this, we are taking only f of t, that is sine ht. Here we will apply L of sine ht. The result what we are going to get, what we are going to obtain, there s is replaced by s by 3. So we have written 1 by 3. Here sine ht is there. H is dominating. Immediately, while recalling the formula, it should strike in our memory that between the terms, compulsory negative sign is there. So in this result, s is replaced by s by a. Our a is 3. So this is the simplifications of which we are doing. So after doing the simplification, 3 by s square minus 9, this s is replaced by, according to change of scale property, s plus a. Our a is 3. So we have done this, so all the simplifications. Final result we obtained it 3 by s square plus 6s. So next problem which is there in our question bank, that is L of 1 minus e power t, which is divided by t. Then first we are a numerator part we have taken. L of 2 terms are there. First one is 1, the second one is e power t. So here we are using the linearity property, which plays a very, very vital role in our problem solving on Laplace transform. With that property only, Laplace of 2 terms are there. We are writing, separating Laplace of each term. L of 1, the elementary function, 1 by s. E power t, the t coefficient is here, plus 1 is there. So s minus 1. This is some sort of remembering purpose. Here plus is there in the formula minus. Here minus is there, plus. Is there any like this the track to remember? Anyway, we have to adopt easy way to remember the formulas. Now f bar of s. That means L of f of t, the work is over. But our question is not only L of 1 minus e power t. The question is 1 minus e power t, which is divided by t. Then if f of t divided by t, the formula we have to see. The formula is, for this divided by t purpose, integral s to infinity ds to be done. The numerator part we have assumed f of t. and we obtained, this is the result, divided by t purpose integral s to infinity f bar of s ds. And we will do the integration. We will obtain the result. So this is the steps to be followed to solve this question bank problem. The next problem is find L of integral over 0 to t e power minus t cos t dt. So L of f of t. So we are taking this f of t. First we will solve that one. Very simple one. This is multiplied by e power minus at or at. Immediately it should ring in our mind. We have to move towards fast shifting theorem. That is, we have written cos t. Here the particular place, our a, the t coefficient is -1. So what is the result we are going to obtain after applying L of cos t? S is replaced by s plus 1. Just opposite will be taken. L of cos t, this is the formula, s by s square plus a square. Our a is 1. In this particular place, s is replaced by s plus 1 for this purpose. So we replaced it. We obtained, this is the result, f bar of s. F bar of s, it's nothing but L of f of t. So now, this is our main question. Only we concentrated, we focused, some part of the question only we focused it in this particular slide. That focusing part of the question we obtained f bar of s. Now that integral over 0 to t dt, integral theorem of Laplace we have to apply. That is, this is the integral theorem. What is the result we obtained? That is, just now we obtained f bar of s, that is divided by s. Very simple, this Laplace integral theorem. So the result, we obtained this one, which is divided by s. So the next problem, which is in our question bank, f of t. Here the t lies between pi by w and from pi by omega, t lies between 2 pi by omega. If t lies between, according to this limit condition, the function is sine omega t. Other t lies between pi by omega up to 2 pi by omega, the function is 0. So here, from 0 to 2 pi by omega, there is a periodic function. So now the Laplace transform of the periodic function formula is 1 by 1 minus e power minus, this is nothing but capital T. That is a period. The question we have seen it 0 to 2 pi by omega, the t is replaced. Integral, this is capital T. E power minus st f of t dt. The periodic function. So we know the Laplace transform formula, that is integral 0 to infinity e power minus st f of t dt. Whereas Laplace transform of periodic function, in the place of infinity, the capital T will be there. We have to do the comparison study among the formulas. Now, 0 to 2 pi by omega, from starting is 0, ending is 2 pi by omega. that is according to our problem condition, but it is a break, it is there. Because the function which is given 0 to pi by omega, one function, pi by omega up to pi by omega, so we divided the given this integral into two parts. The first x lies from 0 to pi by omega only exists for this function between this limit, the function which is given in our question 0. So the second integral is vanished. Only the first integral exists. So the first integral, which is written here, exponential and trigonometry. Put together the formula which is available, we are recalling. After recalling, what is A in our problem? Minus S. B here is there is omega. So that correctly we are substituting in the particular respective places. Lower limit 0, upper limit pi by omega. Substituting, we will attain to the result. All the problems are the important points we are discussing, as more questions should go on. The complete solution already I told, that is the separate videos are done. Those videos complete the step by step, the solutions are explained. Now, so far we discussed about Laplace transform. Now we will move to inverse Laplace transform. That is here s plus 2 by s square minus 2s plus 5, which is given. Here L inverse of, which is written s plus 2, the same question we are reproducing. So L inverse of inverse Laplace. So the operator is L inverse. So L inverse of, we know the format, s by s square plus a square or a by s square plus a square. So the elementary functions, those inverse is very easy. But the question what we have, this to inverse find, it's very difficult. So to bring what are the formulas which are available with us, according to that, better we will modify our problem question towards that. For that purpose, the file we are writing in such a way, 4 plus 1, this work why we are doing to fit what is the already defined formula, this problem to be fit in that place. So now this put together 1, 2, 3, we are writing a minus b the whole square formula plus 4. Now we are noticing here s put together, here minus 1 is there. The top also numerator s is there. Even that s, if it has minus 1, we will be very comfortable. That is L inverse of f bar of s minus a. In this format it is there. This minus a purpose we can write it e power at, which is the inverse formula which is available. But unfortunately, this s is not having the minus 1. Mathematically, suddenly we can't introduce minus 1, but balancing we can do it. So add and subtract 1. So we have done add and subtract. What I am circling, this put together. So it is written, this combined plus 3 which is written. So we can see it here. This is one term, 3 divided by another term. So 2 terms, Here actually L inverse Laplace also, that a linearity property using separately, which is done. Now here s minus 1, here also s minus 1. This minus 1 purpose, we can write it. This is the property just we have told now. Linearity property, which with the help of that, L inverse of first term, L inverse of second term, which is written. We can see it here. We are using the fast shifting property. For that, here we can see it, minus 1, that is minus a. For that, e power t. A place here minus 1 is there. E power t, the remaining one, where I am putting the ticks, they are written as it is. Yes, I put it tick, but the power it has square, so s square. Here also, minus 1 is there, e power t. But there is a doubt here. The numerator also is there here, but the numerator, we have to be very careful while applying the formulas. S is there. Here S put together the format S minus A. In the first term, numerator as well as denominator S is there. So minus 1, the format. Whereas the second one, there is no S term. So the denominator, this minus 1 purpose, e power t, which is applied. The leftover is 3s square plus 4. Looking at this, yes, the numerator s is there. Immediately cos the trigonometric term, it should come in our mind. Between the denominator, positive it is there. There is no h at all, only cos at. Our a is 2 square. So this completely we can replace it by cos 2t. Similarly here also, s square plus a square is 2 square. The top should be 2 should be, but the 2 is missing. So divide by 2, multiply by 2, we can do it and we can apply the formula in the respective places. So we can see it what we have discussed it. The 6 how it is occurred also we explained now. Very simple way. This is the cos 2t. This is regarding sin 2t. E power t we have taken common out. The result we obtained it. Now the next question is find the inverse Laplace transform of log of s plus 3 by s plus 4. L inverse, the symbol which is kept. So f bar of s, we are taking the equation. Logarithmic formula we applied. Log of a by b, which is equal to log a minus log b. We are taking inverse Laplace on both sides. That is L inverse of two terms. First term, second term, we are applying. So using the linearity property, it is separated. Here we want it. We are going to find L inverse of logarithmic term. We are going to apply the derivative of inverse Laplace formula. For that, we are finding both the sides. First derivative we are finding. So here we can notice it. The small dash which represents first derivative. For this, the first derivative is 1 by s plus 3 because log x, we know the differentiation is 1 by x. Similarly, this is also done. So now, here is the inverse Laplace transform of derivative formula is formula in general n times we are doing derivative, which is equal to minus 1 power n t power n f of t. In our problem, only one time we have done the derivative. So here n place we can substitute, we can replace n by 1. So we replaced it wherever n, it is replaced by 1. F of t, it's nothing but L inverse of f bar of s. How this is obtained? L inverse of f bar of s, it's nothing but L of f of t. Cancelling f of t, we are getting. So f of t, which is replaced by L inverse of f bar of s. This is e power minus 3t, because plus 3 is there opposite, plus 4 is there e power minus 4t. So this simplification, which is done minus t, L inverse of f bar of s is the question what we have taken, which is written. So the more simplifications doing, we will obtain the required result. So the next problem is, which is in our question bank, L inverse of s by 2s square minus 1. We are taking only part of the question as f bar of s, that we are taking both the sides L inverse, but we have the formula with us, that elementary functions formula, s square plus a square or s square minus a square. So this 2 is not required to fit such formulas. For that, our aim is to better we will take it outside. So for that, we have taken the 2 outside. Then this is the simplifications. We obtained it. S square minus a square. The 1 by 2, which is in the place of a square. So 1 by root 2 the whole square. This can be written as it is. Here we are doing the LCM. Here, according to that, it's not LCM. 1 by 2 L inverse of 1 by 2, which is written. Here the top S is not there. So the number, that means A is there. Our A square is, in which A is 1 by root 2. So the top also A is required, that is 1 by root 2 is required. 1 by root 2 suddenly we can't introduce, multiply and divide. So which is multiplied, this is divide. That is a reciprocal form. So this occurred in such a way to fit the formula a by s square minus a square. To fit this, we are doing this simplifications. So sin h t by root 2. So now part of the problem only we have taken. F of 0 we are checking. The t place we are putting 0. Sin 0 is 0. Now f of 0 equal to 0, and our f bar of s, which is part of the problem we have taken. Our problem which is multiplied by s. Then what is the result we obtained it? We have to find first derivative. If this formula for fitting f bar of s should be multiplied by s, such problems we have to apply this formula. So we can see it here. This part we have taken, we have solved it. So here splitted one it is written. So first derivative of this, what we obtained the result, that is 1 by root 2 cos h t by root 2. Again the t coefficient is 1 by root 2. So the important steps of this problem which is discussed. So the next problem we are saying L inverse of 1 by s of s plus 5. So here we are taking a part of the equation as f bar of s. We are taking inverse Laplace on both sides. We have taken this is plus 1. So the result is opposite e power minus t. But this part only we have taken, we have obtained this is the result. But the complete problem is this one. Division by s. The formula is this one. That is f bar of s, which is divided by s, this formula to be applied in this problem. We obtained f of t, but in the formula f of u is there. So wherever t, we will replace it by u. So we replaced it e power minus t, which has become e power minus u du. We have to do the integration and we have to substitute the limits from 0 to t to obtain the final result. So this integration we have done it. That is e power minus u divided by u coefficient is minus 1. So minus e power minus u from 0 to t. We applied upper limit minus lower limit. The lower limit e power 0 is 1. The final result is minus e power minus t plus 1. So the next one is convolution theorem. It's a very, very important questions which are in our question bank. That is L inverse of 1 by s square plus a square the whole square, which is given. For that 1 by s square plus a square we are taking as f bar of s. The second one g bar of s. So this is f of t is nothing but L inverse of f bar of s. For this L inverse we are finding L inverse of 1 by the top a should be there to fit the formula of sin 80. So multiply and divide by a we are doing 1 by a. For this the formula is sin 80. The same similar treatment we are giving for the second term also. We obtained the same result. So this is our equation, that is L inverse of 1 by s square plus a square the whole square. So 1, 2. The product multiplication is there. So this is the product of f of t and g of t. The convolution theorem formula is integral 0 to t f of u g of t minus u du. So we are substituting in the particular place f of u. Already we obtained f of t. We need f of u. So t which is replaced by u. Here also we obtained g of t. T is replaced by t minus u. And this 1 by a square. Here the 2, how we obtained it. Here also 2 should come. That is 2 trigonometric terms are there. Whenever 2 trigonometric terms are there, relevant to sin A, sin B. The formula we have to apply. We have to do the integration. And finally, the limit to be substituted to find the solution of this particular problem by using convolution theorem. So the next problem also, L inverse of 1 by the first 1 by s plus a we are taking as f bar of s. 1 by s plus b we are taking as g bar of s. F of t we are obtaining very easy way we can obtain plus a e power minus at. The same here plus b is there. Here we can notice it e power minus bt. F of t we obtained, g of t we obtained. So the convolution, this is the formula, the product of f of t and g of t, which is equal to 0 to t f of u g of t minus u du. Here, what we obtained, the t which is replaced by u, for which the t is replaced by t minus u. Here, according to exponential law, the terms are splitted, and we will do the integration with respect to u, and we apply the limits to reach the final solution. So the next problem is the Laplace, which is used. Its application is differential equations, how to solve. Here, which is given second order, the equation. So the given equation, the format we are writing. We can write d square x by dt square. It's nothing but x double dash plus 3x dash plus 2x, which is equal to e power minus t. We are going to take a Laplace on both sides. This initial conditions which is given at the point x equal to 0, the x is at the point, that is, sorry, t at the point t equal to 0, x is 0. At the point t equal to 0, the first derivative of x is 1. The linearity property, that is L of 3 terms are there. We can write it L of each term here, which is written here. Here we are applying the derivative formula to the second derivative is there. So we are starting from s square. We can notice it, s keep on decreasing. L of x, x of 0, x dash of 0. What we have done, we applied the formula in a correct way or not. Easily we can check it. That is, two derivative, we will start with s square. Suppose in the question in the place 3 derivatives is there, s cube we will start. If it is square, the ending will be 1 less 1 derivative. Suppose in case here 3 is there, here 2 will be stopped. If not, we applied the formula in a wrong way, which gives an indication to us. Next, 3 which is written. Now the first derivative, so s we will start. S L of x minus x of 0. This is written as it is and right side as it is. We are substituting x of 0, the initial condition which is given, 0. X dash of 0, they gave the value 1. So in the respective places, we substituted those values. After substituting, we are doing the simplifications of it. So now, this is very easy one. 1 by s plus 1. In this side, L of x, we will take it as a common term. L of x of sum, which is equal to 1 by s plus 1. So L of x equal to, which will be written, this is also, we will bring this side, x equal to L inverse of that particular terms. So in the application, that is the differential equation, we will start with the Laplace on both sides, finally ending inverse Laplace to be found. So the next one is, here this is the equation, the second order which is given, 4y double dash plus pi square y which is equal to 0. So now here at the point x equal to 0, y equal to 2, the first derivative at x equal to 0, the first derivative of y, the value which is given 0. So the given equation we are writing, which is written, our Laplace we are taking both the sides. Using linearity property we have taken inside, and this y, the double dash derivative formula which is applied, this is also which is written. These conditions what is given, this to be applied in the particular respective places. After applying L of y, we will take it as a common term. So L of y, which is equal to other terms and all, we will push it to right position. Then y equal to L inverse of that particular term to be found. So this is the way the application of Laplace transform to be done. So we can see it here, the steps also which is given. So we have done it, L of y is common. This is a common one. L of y equal to, we obtained 8s by 4s square plus pi square. So y equal to L inverse of this particular term. So another one, remembering the equations which is there in our equation bank system, multiplication by t. That is the f of t which is multiplied by t power n, the formula which is minus 1 power n. If t is t square, 2 times we will do the derivative n times. So t has the power n, so we have to do the derivative n times f bar of s. If it is division by t, this is the equation which is there. F of t by t. L of f of t, it's nothing but f bar of s. This divided by t, that is regarding integral from s to infinity, we have to do it. Unit step function, it's nothing but if t lies between a less than a, the function is 0. If it is greater than a, the function is 1. That is unit step function at the point t equal to a. So these are the remembering the formula equations which are there in our question bank. So we can see it now. This is also a very important question, the starting only, which is where the exponential order, that is our Laplace transform existence. The first condition is piecewise, the second condition is exponential. For that, here, if it is said to be exponential, limit t tends to infinity, this f of t, whatever the function which is multiplied by e power minus st, it should be a finite quantity. It should exist. It should not be infinity. Now, ours we can check it, f of t equal to t cube. First, the f of t, this is a formula replaced by our given question t cube. T cube, this e power minus st, we can see it here, the t cube divided by e power minus st, from numerator to denominator we push it. The t, if you substitute infinity, which is in the format of infinity by infinity, that is an indeterminate format. If it is there, we will recall what we studied in lower classes. If it is indeterminate form, L'Hospital rule to be applied. So according to that, we have to do both the numerator and denominator differentiation. So 3t square divided by e power minus st. Still, t place we are applying infinity, indeterminate form. Again we will do 6t by e power minus st. Still, we are getting one more time. So we are obtaining 6, that is 3 factorial by e power minus st s cube. We are applying the L'Hospital rule. The differentiation. So when we are doing the differentiation e power st, the first time itself the coefficient will be coming. Yes. Second term s square, third time going s cube. Because the coefficient of t should be multiplied. That's what here s cube which is occurring. So now if we apply the final one, 6 by infinity. Infinity we know it. That is 1 by 0. 6 divided by, we are getting 0 by 1. 0 by 1 which is equal to 0. Yeah, finite quantity. So now this Laplace, we have to apply it. We can see it here. That is integral e power minus st f of t dt. This f of t, the function is t cube. This integration to be done. That's what this is the step. T cube, we are going on doing the differentiation. E power minus st integrated one first, which is written. Keep on, we are doing the integration. The middle, they are dominated, the signs are alternative. 0 to infinity, e power minus infinity is 0, e power 0 is 1. Keeping that value in the mind, we have to do the substitutions. So after doing the substitution, the final result, we are obtaining 6 by s power 4. So the one more the problem, here we can see to evaluate, this is the integral t square e power minus 4t sine 2t dt. The value is 11 by 500. Here we can see this is our given question. It's a very important problem in our question bank. That is t square sine 2t. The three terms are there in this particular question. Only we have taken the two terms. This term, which is not there at all here, what we are doing, what I am circling, one integral and this dt. It's nothing but L of, because we know the Laplace formula, L of f of t, it's nothing but integral 0 to infinity e power minus st f of t dt. So what I circled, it comes under L, where S is playing the role for. It's a very, very important problem to understand Laplace transform applications. We are defined the formula, how to apply in a correct way. This is the best problem. So now, first only we are finding t squared sine 2t. Again, t which has the power. So the t power n formula we have taken. So minus 1 power n, our n is 2 square. 2 times we have to do the derivative. This L of sine 2t, a by s square plus a square. Here, our a is 2, so which is written. Next, the first time we are doing the derivative. 2 times to be done. The 2 which we kept it outside. When we are doing the first time, this is the result we obtained it. What we obtained the first result, one more time we are doing the differentiation. Finally, we obtained, this is the result. Obtained the result, the final one, yes, to be replaced by 4. So we can see the steps here. So the final result, we put it yes place, that is replaced by 4. So 4 of 48 minus 4 by 20 the whole cube, which is equal to 4 of 44, 20 into 400, if you simplify, 11 by 500. So up to here, we obtained the first derivative. We can see it, this once we can see of this, minus 4 which have taken outside. This again u by v, that we applied it here. Then we obtained this is the result. So here in this, very, very important steps are explained. So we obtained the final result, 11 by 500. So we will come to a conclusion of this topic, Laplace transforms question bank discussion. We discussed so many problems in the which are occurring in our question bank, how they are defined according to our Bloom's taxonomy. The first level, remember. The second level, understand. the third level apply. The three levels satisfying the question bank which is framed. We discussed important steps, but the complete the solution already I told all the problems complete solutions which are available and a Laplace transform 11 videos are there. We can utilize that. First, we discussed Laplace transform, the definition, integral 0 to infinity, whatever the function, suppose if it is f of t, which is multiplied by e power minus st f of t dt, where s is real or complex number system. L plays the role of Laplace operator, L inverse, which plays the operator of inverse. In Laplace transform, linearity property using, that is a common property for Laplace as well as inverse. The concept of Laplace, that is a linearity property concept, which is Laplace of or inverse of two or more functions. We can write Laplace or inverse of each their sum. And so many properties we discussed: first shifting, second shifting, multiplication by t and division by t, integral theorem and derivatives. Everything we discussed under Laplace and inverse Laplace also. Questions based on this, 90% of our question bank, which is framed following Bloom's taxonomy, three levels questions satisfying, which are framed it. We discussed at most how much possible. Applications of Laplace transform, that is, we are starting with the Laplace transform and applying the initial conditions values. Finally, we are ending with inverse Laplace transform. So in detail, we discussed the question bank or the problems. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.